So I was born into a naval family. I was a very, very strong student. I was many grades above my level. And my father felt that the Navy was a good career for me, and I didn't know any better. So I joined the Naval Academy at a very young age, about 15 and a half. It was clear within the academy that I was not the right guy there. I was too much of a math guy. But then it turned out that my break came because we had a war with Pakistan in 1971, and we lost a naval ship. So the Navy turned to me saying, can you do something about that sonar? Because that sonar was on other ships. So that made my career. So the Navy completely sold out to me saying, okay, Paul, you look in whatever you want, we'll back you. I spent a year in the UK as a research fellow. The Navy supported that. And I came back and I did a very large project, a fleet sonar for the Navy. So the reward for that was 2 years anywhere in the world.
I got a letter from him saying that he would like to come and work with my group. He was very bright. He was, my work is somewhat mathematically oriented, but engineering still. And I think he was the only one who managed to follow the lectures. So our group was working on problems in direction finding. This is, you have signals coming from different directions. You want to determine where they are coming from and how many and so on. Paul was active in that and invented some particular algorithm called Esprit, which became quite popular.
So when he came back to Stanford in 91, the idea was to write a book on Esprit. Sonars had these big arrays, these transverse arrays, hundreds of elements. The idea of the arrays was not used in wireless. I did some practical experiments with it. I was using some colleagues to run around with phones to recreate a DARPA problem. And it turned out it rained one day and we brought the equipment in. And the two students had come to talk to each other and they were holding phone next to each other. And I found I could separate it. And they said something here is wrong. If I transmit from an antenna, it arrives as antennas with a signature. If I transmit another antenna some distance away, some different angle away, I get a different signature. If these two antennas were next to each other, and this guy was hundreds of meters away, you would expect they will have the same signature. But I found they were completely different, even though they were millimeters away. That was shocking. And a few days later, while actually having a haircut, I realized that could be exploited, and that started the MIMO world. It was rain and good fortune.
The impact is basically a factor, and realistically maybe a factor of 3 or 4 improvement in the use of spectrum. So it's like getting 3 or 4 times the amount of spectrum.
Initially, everybody was skeptical because this was promising things which seemed just too difficult to do. And in 1998, I formed my first company to commercialize MIMO in cellular networks. So we actually built a full system, amazingly. But in wireless, you have to have a standard, otherwise you can't grow. So Intel bought the company.
The company promoted something which is called WiMAX, which used very effectively the modern technologies, including MIMO. It is essentially what we call LTE and 5G today.
And I said, okay, now the standard is going to happen, let me go and build a chip company. So I started another company called Besim to build chips for 4G.
After I graduated from Stanford and joined Samsung Electronics in Korea, I was doing the next generation communications research, which back then was 4G. Now our paths crossed as partners in mid-2000s, me at Samsung and him at Besim that he founded. MIMO, together with OFDM, was finally introduced, revolutionizing high-speed wireless services with significant improvements on data rate and system capacity. MIMO OFDM still serves as the fundamental baseline of 5G and Wi-Fi technologies and products today.
There's tens of thousands of engineers, 25,000 patents, number of books, thousands of PhDs. So I just started the spark, but then it's a huge effort. The fact that you have it today in the phone is the work of many, many people.